Hi students, so today we're going to take a look at a practice exam for AP Computer Science Principles. It's a 2-hour exam, 74 questions, and on the screen it actually says that this is 60% of your total score, but the reality is the test has changed and 30% of your score is down to one single project, which is the create task, and 70% is now going to be calculated from your results of this test. So I'm working on a PDF on the screen. I'm going to scroll down, zoom in and out, and kind of scribble some work on the side. So hopefully you guys can follow along. So for question number 1, over on the left, top left, it says you won the lottery and you elected to receive a lump sum. So you wanted the whole amount in one go instead of it being paid over multiple years. It says the largest number the bank's computer can store is 2 to the 31. And then it says, or what is that? That is $2,147,483,647. It says after depositing your lottery winnings of it looks like 2.5 billion, what will the result be? Well, the 2.5 billion that you're trying to put in the bank is more than what the bank's computer can store. And so when that happens, when you're trying to fit a number that is too big for the computer's memory to hold, and you know, a computer can hold a lot of information, right? But what this means is that the number is too big to store in the place that the bank has reserved memory for. So it's not like the bank is going to use all of its resources to store just your balance. They have to decide what is a reasonable amount per account to store as a balance number. So here, when you have this problem, it creates what they call an overflow error. And so for A, it says your winnings were more than the largest number that the bank's computer could hold, and therefore an overflow error will occur. And so it's really just this piece of vocabulary. When you're trying to put a number that's too big for a space, you get an overflow error in this way. So that is actually the answer for number 1. You can go through the others, but overflow error is it. Okay, for number 2, it says you stop and purchase your favorite snack after school one day. You notice that the cash register shows the change you are owed is 0.049999. rather than rounding it up to 0.05. How is this possible? And so A says the cash register display procedure has an error. Now, that might seem like it is reasonable, but if it's programmed correctly, the display should show, should know that it's dollars and cents, and it should allot a certain number of units for you to see that number. So B, it says, since decimal numbers are stored imprecisely in computers, a rounding error has occurred. And so, in fact, B is the answer for this, and it's to do with something called floating point. And so floating point numbers, let me just write it. Floating point. These are numbers that are not integers. They're numbers that are like fractions. And they are stored imprecisely in the computer and sometimes can cause these rounding errors. And so for monetary transactions, they shouldn't use floating point in terms of like fractions. They should make sure that they have, only 2 decimal places after the point to the right. So in fact, because it is being stored imprecisely, it's going to be a rounding error has occurred. And that kind of makes sense. They didn't round it correctly here. Okay, for number 3, it says you are assigned a parking space in a large parking lot by an automated machine. You recognize that the parking space number is displayed in binary. Okay, so I'm going to circle or underline these important words. It says the parking spots are labeled in decimal numbers. So it says that you recognize that a parking space number is displayed in binary. So that's how it's displayed. But the parking spots are labeled in decimal. So you need to convert the parking space number this to decimal to figure out which spot you've got to park in. So what we do is we count them 1, 2, 3, 4, 5, 6, 7, 8. So we've got 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to rewrite it 1, 0, 0, 1, 1, 0, 1, 1. And because this is binary, each space is only a 0 or 1. But they have a place value. This one is worth 1. This one is worth 2. This one is worth 4. And they kind of double. And these numbers come from this being worth 2 to the 0 power, this being worth 2 to the first, 2 to the second, 2 to the third, and so on. So when we have a 1 in the ones place, we would calculate it by doing 1 times 1. When we have a 1 in the twos place, we would do the 1 times the 2, and that would give you the 2. And then we've got a 1 in the 8s, and then we've got a 1 in the 16s, and then we've got a 1 in the 128s. So if we multiply all of these out, it's pretty easy because it's just 1. And then if we add them all up, so this is going to give me 10, that would make 26, 27, so I got 27 plus 1, 28. So that gives me a 5, 1, 5, 155 is going to be my answer. So that is the answer for number 3. All right, we're halfway through the first page. Okay, so question number 4, it says, when designing a web page, you see a color you want to use that is listed as hexadecimal. So hexadecimal is base 16. So it's different to binary, which is base 2. And with hexadecimal, we can have digits from 0, 1, 2, 3, all the way down to 9. And if you count them, that's going to be 10 different digits, right? And the value of each of these is their face value. So number 3 is worth 3, and number 9 is worth 9. But then we go to A, which is worth 10, B, which is worth 11, C, D, E, F. In total, there's going to be 16 things here. So we've got 0 through 9, which is 10 things, and then A, which is 11, 12, 13, 14, 15, 16. So we've got 16 different things, but be careful when you are labeling the value of them. So this is worth 12, 13, 14, 15. And you might think, well, surely F should be 16, but it is, F is the 16th digit character that can go here, but because we have 0, 0 is worth 0, and if you keep counting up, 9 is worth 9, A is worth 10, and so on, F is worth 15. So when you see a hexadecimal color, we split them up into pairs, and the first bit is the red, then we have the green, and then we have the blue. Now, colors can also be represented in decimal values, and this would be 3 kind of like numbers with a comma between them, and that's from 0 all the way up to 255. So that's how this would be. But the first number would be the red, then this would be the green, and then this one would be the blue. So it says, which color is this out of these decimal values? Well, so I'm going to write this bit in red because the first one, the 5 and the 0, is representing the amount of red in this color. Now, because it's hexadecimal, it means this is worth 16 to the 0, and this is worth 16 to the first. So 16 to the 0 is worth 1, 16 to the first is worth 16. And so the value of this is 5 times 16, right, a 5 in the 16s place, plus a 0 times 1, because a 0 in the 1s place. So 0 times 1 is 0, and 5 times 16 is going to be 80. So the value of the 50 in hexadecimal is worth 80. So as you look down, the reds, there's the 80. There's no other 80 here, so that's your answer, and you can move on. If you had time and you wanted to check, or let's say you had multiple 80s here and you needed to then move on to the green and the blue, you could definitely do that. We'll do the other two as well. So the amount of green is C8. So C8 is representing the green. Now that C over here is worth 12. So this is you've got to be very careful in this. So the C is worth 12 and the 8 is obviously worth 8. And that's a 16 in the zeros. This is a 16 in the ones. So the value of this C8, how we find the value is we have 12 in the 16s place, and then we have to add 8 in the ones place because 16 to the 0 is worth 1. So when you do the math here, 12 times 16, well, 10 16s are going to be 160 plus 2 more. Well, 2 more is 32. So 160 plus 32 is 192. And then 8 times 1 is 8. So when you add them up, you get 200. So the 200 here matches. And if we wanted to do the blue just to round it off, I'm going to come back over here. So the blue value is worth 7 and 8. So a 7 and an 8. So remember, this is kind of 16 to the 0, which is 1. This is 16 to the 1, which is worth 16. So the value of this is 7 times 16 plus 8 times 1. So that's going to give us 7 times 16 is going to be, well, 70 plus 42, right? 7 10s, 70, 7 6s, 42. So that's going to give us 112. And then the 8 times the 1 is going to be 8. When you add them both together, that gives you 120. So that does match here. So yeah, quite a bit of work. But once you found the 80 for the amount of red, I would just move on to question number 5. All right, so I'm scrolling down right here. Number 5 says that you are designing a UI, meaning user interface, which is really like a display, something that has buttons that people can click on, for use by multiple international travelers. How can you best communicate the options and features of the software program so that most people can understand them? All right, so key things here, right? So we got international travelers, so people speaking different languages, perhaps, right? We need to communicate options and features of the software programs that most people can understand them. So for A, it says write the UI in Spanish and Chinese, 2 of the most common languages spoken worldwide. Well, that might be true, but just because those languages are the most common doesn't mean that that's going to satisfy most people, right? Because most people in the world do not speak those 2 languages. Even though they are very, very popular, there's more people who speak collectively the other languages. So B says use an API to interface with a translation website for those who need it. So, you know, that kind of seems like it might be reasonable if there is a way to take whatever you've coded onto the display, and if somebody comes along and presses a flag that's for a different language, then it would translate things. Maybe, let's keep reading. So provide a link to an online dictionary so that words users do not know can quickly be looked up. Well, that might help some people, but it's not going to help everybody do that. And we have other issues with context or even just translation services in general not really working automatically to provide accurate translations, right? And then D says use images to represent features of the program. So that seems like if you can replace the word, you know, close with a big X to let people know to quit the program or to exit, or with an arrow back, then most people are going to understand how to do that. So D is definitely the answer here. For a user interface, we're looking about making buttons and images and information very clearly like labeled and easy to use. Okay, number 6. Number 6 says the principal hired the programming class to write a program to reserve parking spots in the student parking lot. She wants seniors to have the best spots. Okay, so that seems like it's important, right? Seniors are going to have the best spots. It says, what is the best way the programming class can verify if a student is a senior? All right, so they need to check if the student is a senior so that they can get the good spots. So it says the program can loop through the school district rosters for every student name. Okay, well, there needs to be more about it, right? Just getting the name isn't going to help. You need to know what grade they're in. And then also school district. Sometimes there's multiple schools within a district. We've got middle schools, elementary schools. Those folks aren't really driving as well. So that one doesn't really feel like it's right. For B, it says grade can be an input field that is then passed to a procedure to select an available spot. That seems like it's important, right? It needs the grade to figure it out. If it passes it to a procedure, so that's going to be like your algorithm, or in Scratch when we were making custom blocks, that would be kind of like the variable that's passed in. That is data in that is then transformed to produce data that comes out. So B is actually feeling like the best answer so far. Feel really good about it. Let's keep reading though. It says use an API to integrate with the school's information system hosted off-site to check the grade level. So use an API to integrate with the school's information system hosted off-site to check the grade level. You know, it's quite general. It feels like it kind of might be right, but the API is when the school's system or any program will connect to receive more data from another system. The API is the way that it is the thing that it uses to connect to another system. So this assumes the information system is hosted offsite, which really depends, but it's not feeling as good as B. So it does also say here, what is the best way? And you might find that as you read these that you have to really kind of like go through these and really like navigate them to get a good sense of which one is correct. Okay, so for D, it says have students upload a photo from the school registrar showing their school grade with their parking spot request. So again, that's another way to get the grade up there, but it why would that not? So have students upload a photo from the school registrar showing. So if they upload a photo, what's that got to do with their grade, right? It feels like it's not right because of that, you know. And if they're taking a photo of their ID card, could the grade be changed? Why do they need to take a photo of an ID? You know, it doesn't really feel all that right. So B is the correct answer. And so within the notes for the answers, it says using a parameter with the procedure to integrate the grade is the best solution. Due to security and privacy risks, students should not integrate with the school system database. So adding a step to upload a photo is inefficient, as is a loop to go through the district rosters each time. So that kind of makes sense, right? So going through the whole district's rosters of every student every time somebody's trying to be assigned a parking spot, that seems quite inefficient. All right, we're going to scoot down. We're going to go to number 7, which is right at the top right now. So for number 7, it says you have to change a program written a year ago by someone else. A sample selection of code is below. How could the original program author have helped somebody? How could the original program author have helped someone making changes at a later date? All right, so this brings to mind that comments should be used in code. You know, this is a tiny piece of code over here. We got something that's called procedure A, that has these 3 parameters going in. And then it checks if x is less than, so whatever the first number as a parameter is less than y, it assigns z to x. That's what it does. But it's quite abstract. We don't know what x, y, and z are representing. We don't really know anything about it. So back to the question, it says, how could the original program author have helped somebody or someone making changes at a later date? So provided the original program requirements. All right, maybe helpful. B, added a video describing the program design and functionality. Yeah, maybe interesting, maybe useful. Okay, C, used procedure and variable names that described their purpose and content. So that feels really good, because as I was saying, we don't really know what X, Y, and Z are, and so programmers are encouraged to use variable names that are meaningful. So that's quite important. And then D, provided written documentation of the application development process. So this documentation isn't necessarily even talking about comments that are in the code that are kind of like lines of text that are not run as code. This is talking about just general documentation that accompanies the program. So, you know, useful again. I think all of them are useful, but C stands out. C is the standout one. All right. So now it says number 8 and 9. So are based on the code below. Assume all lists. It's a little noisy. So it says, assume all lists and variables have been properly initialized. All right, so this is question 10 here. We're going to ignore this for now. We're going to try and figure out what this does for number 8. So we have some variable called ownIt that is assigned as false. Song is assigned this input. So maybe the user types in the name of a song. And then for each song name in playlist 1, so we assume that there's a list called playlist 1, and that every item in that list is called song name. So when it says for each right here, this is basically going to go through every song name in this list. And it says if song name equals song, so if the item in this list is the same as whatever this user typed in, then it's going to play the song. And when it plays the song, it's going to assign ownIt to true. So for each item in this list, if song name is song, it plays it and then it sets ownIt to true. Now once it sets ownIt to true, when it comes down to this next thing, through sequencing, right, we go line by line through the code. After it assigns it to true here, it says if not ownIt, so if the person doesn't own it, right, so if ownIt is false, then it adds playlist 1 song. So it adds the song to the playlist and then it plays the song. All right, so let's really think about what this means. Okay, so it's going to go through every item in this list, and if the input that the person put the name of the song, if that's on the list, actually if it reaches that in the list, then it sets ownIt to true. If it's not on the list, it's going to add it to the list and then it's going to play the song. Right? So we've got a lot of stuff going on here. So ownIt is originally set to false. Okay? For each item in the song list, and for each item song name in playlist, it's going to check if the name of the song on the list equals what the user put in. If it is, it's going to play the song and then it's going to set it to true. If they did not own it, then it's going to add to that list, it's going to add the song and then it's going to play the song, but it's not setting ownIt to true in that case. It's just leaving it alone. So for 8, it says, what does the code do? So does it play a song from the playlist? Well, it does it a lot more than that, right? B, it says, if a song is requested by a user that is in the playlist, it plays it. Okay, well, that's the first part. Otherwise, it adds it to the end of the list, so that's the appending, and then it plays it. Well, that's pretty much what I just described, right? So B is exactly what it does. There's no moving any song from any position. Identifying song user but does not own provides a way to purchase it. There's no way to purchase it. It's not really that at all. Okay, number 9. It says if the code in the code, if play is a procedure, what does song represent in the line play song? So if play is a procedure, what does song represent in play song? So if play is the procedure, right, which we see that's the very last line, says what does the song represent in play song? Well, when it says play song, if we look up, the song up here was whatever the user input. That's gonna be the value of song right here. And so let's take a look. It is the name of the procedure for documentation. Well, it's not. Song is not the name of the procedure. Play is the name of the procedure. B, it is an input value where the user requests the song to be played. Well, that kind of feels good, right? Like it is an input value. So B feels good. Let's look at C. It is a value being passed to the procedure via an argument that will be used as a parameter in the procedure. Well, technically, that's exactly what it is, right? So this one, it is a value being passed to the procedure, right? When it says play and then song, this is the value that is being passed into the procedure play. Via an argument, it will be used as a parameter in the procedure. And then D, it is an expression that must be evaluated. It's not an expression. It's just the value being passed. And the reason why that one is a little better than B, let's take a look. So it's an input value. You know, technically over here, this is the input value here. But once it's assigned to song, the computer doesn't really know it's an input value at that point, right? So it might have originated as this input value, but song itself is really just this thing. It's just a value being passed. All right, so that was number 9. Let's take a look at 10. So it says, which statement is not true? So here it says, lower level languages are easier to debug. So, no, really quick heads up. When we're talking about lower level, higher level, lower level, higher level. Okay, so this is one way to think about it. High level, low level. Okay, so with high level programming languages like Scratch, this is where like you see these blocks like move and then so many steps, right? So high level languages, they kind of hide the detail. They are more abstracted. Okay, and low level is where, you know, whether we're dealing with like C++, that would be more low level than say Python, which is easier to read. So low level are definitely harder to read. But these languages, they can all do the same thing. It's just whether more detail is shown or not. So let's go through them for number 10. It says, which statement is not true? Be very careful with this. So low-level languages are easier to debug because the language is closest to what the computer executes. It might be true that the language is closest to what the computer executes. That bit might be true, even though really it becomes ones and zeros in the end, but it is closer to that, but it is not easier to debug. It's because it's harder to read it for humans. So debugging is really a human activity to debug. And so having language that is closer to what the computer executes is much more difficult. So A is actually false, so it's not true. So the others should be true. Higher level languages are easier to debug because the language is closer to natural language. That's true. C, lower level language provides less abstraction. That's true, right? Right here we said higher level is more abstracted. And then higher level languages are easier for people to code because they are more like natural language. That is also true. So our answer for 10 is A. Okay, number 11, if a simulation of the solar eclipse is set up to test the effectiveness of glasses to safely view the sun, which scenario below is most likely if the first test shows the glasses to be inadequate? Okay, so we've got a simulation of a solar eclipse that's really testing if glasses are good, right? So if we've got a pair of glasses, we've got a situation where we have this eclipse that's coming, right? The sun's going to be blocked out. And it says which scenario below is most likely if the first test shows the glasses to be inadequate. So if it happens first and these are bad, then what's going to happen? Most likely. So A, the team can modify the degree of darkness and retest quickly to determine the threshold of effectiveness. So I kind of like that. That one feels good. Okay, B, the team should stop the test and notify the company that makes the glasses. No. Like the whole point of a simulation is to keep testing quickly, right? C, the team should rerun the test multiple times to ensure that the results are valid. You know, if there is some reason why they think it might be an invalid test that one time, then they could run the test again. But to keep rerunning it multiple times without changing anything is a little crazy. So they should really have planned for a lot of those variables. So I'm not really liking C. D, the team should rewrite the code for the simulation. No, if the code should be, you know, set up and believable, and if the simulation was set up, it's not about changing the simulation because of the results. It's about modifying the glasses. This is a test of those glasses. So A would be your answer. All right, I'm scooting down. Number 12. So this is on the left. It says a simulation of conditions for a new sensor to be used with self-driving cars is being designed. Okay, so it's a new sensor. Self-driving cars. The pseudo codes, this is kind of like fake code but easier to read, for the test is below. So when the car starts, turn sensor on and set the incident counter to 0. When detect object 3 feet or closer, redirect. So 3 feet or closer. So when the distance of the object is less than or equal to 3 feet, that's when it's going to move away. All right, and then when it's in that zone, then it adds 1 to the counter. Okay, so which conditions should the simulation test? Which conditions should the simulation test about the sensor? Okay, so if the incident counter is greater than 10, then the sensor is successful. Let's think about that. That would mean that it kept getting close to objects, within 3 feet of objects. It did that 10 times. So I'm not sure if that's a good thing, that it's getting that close to multiple objects. So for B, it says if the incident counter is 0, then the test is successful. So would a car just never get 3 feet to an object? Not sure about that either. Okay, so C, set up objects that are 3 feet, less than 3 feet, and greater than 3 feet to determine the action taken. So that seems like it's a good plan, right? To have objects that are 3 feet, less than 3 feet away, and greater than 3 feet away, and then see if this simulation does the right thing. If it's 3 feet, then it should move the steering wheel. If it's less than 3 feet, it should move the steering wheel. And if the object is greater than 3 feet, it should not try and move away from it, right? So C is looking good. Let's just check D. If the car avoids an accident, then the sensor is successful. Now, it might seem like it's the right one, but just because an accident doesn't happen doesn't mean that the car wasn't doing something reckless. So this is like a little vague, but C is the one that kind of makes the most sense. All right, let's try 13. So a series of binary numbers appear on your computer screen. What do they represent? Okay, so binary numbers can represent like a whole bunch of things, right? So it could represent, you know, every bit of data that a computer is processing turns into binary. So let's just go through them. A, the source code for the program after it's being compiled. Okay, might be a little weird to show it as binary on the screen. The machine instructions that caused the error. I guess whoever programmed it, if they made the error come out in binary, but it would just be weird because humans cannot really read binary so easily, right? Let's try C, the error message before converting it to words using the ASCII. So you would go from binary to real words using the ASCII kind of system, but why would it show it in binary? So D, it is impossible to tell the representation without knowing the context of their use. Definitely is, right? Like, it's just, what do they represent? We would need to know a lot more information, right? So it really is impossible to tell. So that would be D. Okay, for 14 it says, which of the following will evaluate to true? True and true, or true and false? So let's think about this. So these are usually hexagons, right? And they have these are called predicates, Booleans, they're true or false. So here we have something that is true, something over here that is true, and the word and. Now for this whole thing here to be true, we need both of them to be true, which it is. We have a T and a T. So the value of this guy on the left is true. This one over here says true, this one is false. So when we see the word and, they both need to be true for the whole thing to be true. Well, here one of them's true, one of them's false. So this thing evaluates to false. And then if you look at the word or between them, we basically evaluate this whole thing for point I as true or false. Now for this to evaluate to true, one of them needs to be true. And we have that. So this will evaluate to true. I is true. So just quickly scanning the answers, we know it's not C because we need I to be there. Okay? Now the other ones are either 2, 3, or 1, 2, and 3. Okay, so we have to check those a little more carefully. So let's do the middle one. So it says not true or false. Well, true or false, this one's true. This one's false. So when you have a true and then the word or and a false, when one of them's true, the whole thing is going to evaluate to true. But we have the word not in front, so not true now evaluates to false. So 2 does not evaluate to true. So it cannot be this, so that one's gone. And it cannot be this, so that one's gone. So we know that the answer must, in fact, be B. Okay, and we could talk through the next one, but because of the timing of this test, you should skip. All right, number 15 up here. So what is the outcome of the Boolean conditions in the diagram produced at steps 1, 2, and 3? All right, so a false and a false going into an or, well, one of them must be true for a true to come out. They're both false, so that comes out as false. So now you have a false and a true, this one's true, going in here. When you have a true and a false going in, one of them needs to be true, which it is, to be true, so true comes out here. That true continues down the bottom, so here we've got a true and a true. The word and means they both need to be true, which it is. So we have FTT, false, true, true. So looking at the answers, false, true, true looks like it's C, and that's the only one that is false, true, true. Okay, 16, a camera watching an eagle's nest starts recording when a motion detector starts. Which of the following is the metadata? Key thing about metadata, data about data. So the longitude and the latitude of the bird's nest, that is definitely some data. A camera watching an eagle's nest starts recording when motion detector starts. So we'd be assuming that the camera has that. We don't know if the camera has GPS, so we're not too sure about that. If it did, then that would be correct. Okay, B, the date and time the motion is detected. Well, that is also data about data, right? It's not the actual photo or video, but it is other additional information. As long as a camera has that, then that, just like longitude and latitude, that would also be metadata. Okay, C, the number of eagles using the nest. So let's see, the number of eagles using the nest. So the camera would need to be able to count that, and that's something that we would see within the video. We would need to see that within the video, but the video itself is probably capturing the date and time, is probably capturing, you know, like the aperture of the camera, the longitude and lat if it has GPS, but it is probably not storing in the file how many objects it's seeing in there. So I don't really like C. And then D, the number of frames per second that the camera records. So this is, because it's talking about recording, we're now talking about a video camera, right? So when it says a camera is watching, and that kind of makes sense, right? It says it starts recording when motion is detected. So the FPS, the frames per second, is definitely something that would accompany the video. So that is data about the data. So out of all of them, even though A and B are kind of feeling good, like D is more specifically about the frames per second, which we know that the camera will be capturing and keeping. You know, in the answer responses for 16, it says everything is data about the nest and the eagles using the nest except the number of frames that the camera can record, which is data about data or metadata. So this is actually really important, right? Just as a clarification, the longitude and latitude might be recorded, like might be stored in the data files, but that longitude and latitude, you know, it's a little confusing because it's the longitude and latitude of the nest, not necessarily the longitude and latitude of where the camera is, right? So that, I think that's really an important thing for A, is that if it was the latitude and longitude of a camera with GPS, then that truly would be metadata. The date and time that the motion is detected, that kind of feels good because it's when the camera turns on. But yeah, it says it still sees that the date and time that motion is detected. That's really a date and time of something that's happening in the nest, even though when we think about it, it is the date and the time that the data itself is being captured. So that's a little borderline. The number of eagles in the nest is also data about the nest. It's not data about data, right? But the number of frames per second is truly data about data. So D is the correct answer. Okay, for 17, Susie's mother wants a copy of a photo from a family vacation that she took. The picture is too large to email. How should Susie compress the image if her mother wants to print a large copy of it? So let's say that she has a file that is very large, and I'm not even talking about the dimensions of the photo, just like the number of megabytes, right, or gigabytes. It's very large. If she needs to email this, she's going to have to compress it, and then when she sends it, you want the person, generally, especially if they're going to do a really big print of it, you want them to get the original. You want them to see it large again, even though it might have to be compressed in the middle. So we have lossy and lossless compression. So when it says she should use a lossless compression technique, which will be needed to print the version with high enough quality to frame, so lossless means it can be returned to the originals. This feels good, but even with lossy, you don't always lose so much. So it really does depend like how big she wants to print this thing. So let's keep reading because A feels good. She should use a lossy compression technique to obtain enough compression to send the image. All right, but even lossless should be enough to send the image as well. So I'm not really feeling so good about B. And also it doesn't talk about the loss of data when they decompress this thing. So C, they should be combined for the best compression technique. Nope, that's just fake. You're not going to mix up lossless and lossy. And then D says any compression technique will be sufficient in this case. Now D almost feels good, except we don't know how big she wants to print it. So it might be the case that anything will do because she's only printing it like 10 inches by like 7, right? We don't really know that. So you can't just say that. And also, they're talking about lossy and lossless, but there's probably other compression techniques which are terrible. So that's not true. This isn't true. To obtain high enough compression, we don't really know about this. Too vague. So lossless is the only one where she can return it to the original. So A is the answer for number 17. Okay, number 18. When listening to an online music service, you request songs. You request songs like a specific song. How does the music site determine what to play? All right, so when you like songs as you're listening to them, how does that music site determine what to play? So let's read through them. So it plays songs that you have played previously. Well, that's not necessarily recommendations of new songs. And if it only returns songs that were similar that you'd played before, then it's not really giving you like what you request. So A doesn't really feel all that good. B, it plays the most requested song from all listeners. No, everybody has different music tastes. So it shouldn't really just give me what's popular. It should give me what something related to previous music that I've liked. Okay, C. C says it uses data mining techniques to determine patterns in the music that are similar. Well, that makes sense, right? If I'm into like EDM, like high energy music, if I'm into jazz, then it can look at the data behind the songs, and then it can look for similar patterns in other songs and then present them. So C is looking good, and D, it plays a random selection. Well, that's got nothing to do with what I'm liking. So therefore, C is the answer. Okay, number 19, which one of the following would be a good project for citizen scientists? So citizen scientists are when you need a project doing with the help of others, and you reach out to folks organized on the internet, maybe even around the world, to take part and to help in some way. So, which one of the following could be a good project for those citizen scientists? So A, counting pine trees in urban conditions to get accurate data about the spread of the pine beetle. All right, if we're talking about spread, they're talking about different areas, right? Maybe different parts of the state, maybe different parts of the country, or different parts of a town. That would be useful to get people around that town or state to help out. Okay, so B, identifying new stars using personal telescopes to keep costs lower for the tracking organization. Okay, so this, they got a few things in there that help this feel good, like keeping costs lower. Seems like it's a good idea, but personal telescopes probably aren't the best equipment for stuff like this. Not everybody who is online and wants to help out in these things might have a telescope like that. So here there's a couple of barriers. B doesn't really feel too good for number 19. A, reading different genre books and evaluating them so that book publishers know which type of book manuscripts to accept and to market. You would need a lot of people to read a lot of different types of books, and then people have very different tastes in books. So that's the other thing, right? So therefore, that's going to be a challenge, because it might be like a focus group where you get information from that activity, but it's not everybody doing something scientifically. There's a lot of interest and preference there. So this isn't going to be good. And just one other thing here, identifying new stars, that would need to be people who are super, super highly trained. And citizen scientists, although it might be for a science experiment, that might be harder to do because people might not have that know-how. Okay, D, counting fish in a lake to know if the fish are safe to consume. So this is like super niche, and when you think of citizen scientists, we think about them being spread out around the state or the country. And so to have everybody come together, that's not the point of citizen science. So it's not this one. So even though it's a little boring, counting the pine trees in urban conditions to get accurate data about the spread of the pine beetle. So this isn't looking or dissecting a pine beetle, this is just literally counting pine trees in an urban condition to look at the spread. So yeah, A for number 19 definitely makes more sense. Just reading the answer notes, it says projects that are good for citizen scientists would be one where specialized equipment such as a telescope or fish finder would not be required and can be based on facts versus personal opinion. Counting trees would be the best use in this example. And so I think we mentioned those points. For number 20, what describes the process of searching data sets for incomplete data records to process? All right, so even when we think about your student records, you know, sometimes you folks move home, apartment, house, and you might update the address, or you might have enrolled mid-year and some of the data might be incomplete. So the process of searching data sets for incomplete data records to process. So that isn't just classifying, which is putting them in groups. It isn't just filtering them, like getting all of the groups together, getting all of the groups that have similar criteria, qualities about them together. It's not that. And clustering is also a grouping. The actual searching for them and then for incomplete data records to process, this really involves like fixing that data, which is closest to cleaning the data. Okay, so data cleansing or cleaning would be the answer for number 20. Okay, 21 says a teacher wants to determine student opinions of computer science before and after taking a course. She gives students a survey on the, and I'm going to go up the top, on the first and last days of class. The survey includes questions about students' impressions about computer science, if the teacher communicated effectively, and if the teacher was positive about the course material. And if students gave their best effort in the course, what questions can be determined from the survey data? So there was impressions, there was whether things were communicated effectively, positive, was the teacher positive, and if students gave their best. Okay, so it says what questions can be determined from the survey data. So let's have a quick look at the survey data at the bottom. Actually, is this? Looks like this is actually for 22. So just knowing the words up here, it says what questions can be determined from the survey data. If students who moved from a negative to positive impression of computer science after taking the course also thought that the teacher communicated effectively. So it is capturing if students were originally had a negative impression and if they are now having a positive impression. Definitely captures that. And then it kind of would also capture, like at the very same time, in that first day, if the student communicated effectively, but that's only really with the first day's bit of experience they would have done that survey. And then on the last day, they would now know if the teacher did communicate, their opinion of whether the teacher communicated effectively as well. Okay, so, for number, what is this? This is number 21. One kind of feels like it is possible, right? Like they are capturing those feelings about the course and feelings about the teacher. So then 2 says, which students plan to major in computer science after taking the course? I don't think it's asking that. It's not asking who's going to major in it. So I do not see any reference to that there. Okay, 3, if students who did not change their existing view after taking the course gave their best effort. So we could see people who did not change their view, people who were positive and still positive about the course, people who were negative and still negative about the course. The data would tell us who they are. And we could also see if they gave their best effort as well. So 1 feels like it's possible with the data, so does 3. So 1 and 3 is B. All right, 22. Given the table of data about the car accidents, so that's the table at the bottom, which outcome is supported by the data? Okay, so let's read each of them and then go to the data. So drivers ages 16 through 25 have the fewest accidents. That does not seem like it should be accurate, but let's look. So 16 through 25 have the fewest accidents. So we've got ages coming up. Here are the 16 through 25s. Here are all of the accidents. We could add them all up, but just by looking at them, this stuff is bigger than this stuff, and these are 26 to 50. So 16 to 25, definitely a more dangerous group. So A is not supported by the data because they do not have the fewest accidents. Okay, B, more accidents occur on the weekdays. Weekdays, we have this. Weekends, we have this. So more accidents happen on the weekdays? I don't think so. This one's 515, almost 300. More accidents happening on the weekends. So B is not true either. Okay, C, drivers aged 26 to 50 have fewer accidents than the other 2 age groups. So I guess we got to add them. Here are the two other age groups. So if we add them up, oh gosh, so this is going to be 250, 402, and if we add that, it's going to be 494 for this bunch of them right here. This one here is going to be 332, 339, 419. So this is still smaller than this, and then over here, the top 2 added are going to be 526, 626, 628, 708. So it is true that this is fewer than the 708 and the 494. So that is true. C is true. And you could keep looking at them, but you just don't have time during this assessment. So just keep moving. That was up to 22. Okay, so if we take a look at this, this is question number 23 over on the top left. So which of the following is an example where analysis of a large data set would not be able to identify potentially valuable information? So which of the following is an example where analysis of a large data sets would not be able to identify potentially valuable information? All right, so identifying risk factors for certain health issues. So it wants to know what would not be able to identify potentially valuable information. All right, so identifying risk factors for certain health issues, that is something that you would need a large data set for, right? So this is how you would connect it. So I've got to go grab the pen option. So when it's talking about a large data set, we're thinking what is potentially valuable that we can get from this. And keep in mind the answer that it wants is something that is not. So risk factors, it seems like you would need a lot of information because it's not like, like 50% of people have, like some serious condition, right? Some conditions are very, very rare. So we need a lot of people. And then also, even for those, conditions that are quite common, you would still need a large data set to kind of analyze it based on gender or based on age or height or weight or ethnicity and all of those other things. So this is potentially identifying potential valuable information, but we're looking for a not. Okay, for B, it says identifying which aspects of banks should focus, which aspects banks should focus on to minimize loan defaults. So defaults is when people stop paying a loan. Okay, so if they have a large data set of people who have paid off their loans, who have defaulted on their loan, they can kind of, like analyze that data and get valuable information from it. So that seems reasonable as well. Okay, for C, enabling companies to know when to schedule the replacement of equipment parts because of usage and increased maintenance on them. So big data for that stuff seems like it's useful as well for C. I guess if you had a lot of data about when computers started to break, at what age, or when a light bulb starts to break, that all seems kind of pretty reasonable. Enabling business to know what to produce and when to produce stuff for maximum sales. It seems like that, which of the following is an example where analysis of large data sets would not be able to identify potentially valuable information? So enabling businesses to know what to produce and when. If it was something specific to one product that was being produced, maybe if you had enough data on it, you would be able to see sales trends and when things were selling well. The answer in the notes here for 23 is D. Analyzing big data can identify risk factors for all the issues except knowing exactly what consumers will purchase and when. It's D is the answer. I'm not super fond of this because you will be able to look at sales trends. We will be able to identify that there's a peak of buying certain toys before Christmas and all that other stuff. Yeah, I think 23 is just too really vague at this point. Okay, let's just kind of ignore that one. For number 24, why do businesses and scientists attempt to analyze big data? So big data, is kind of what it seems to suggest, that it's a lot of data, a huge amount of data. So then the smarts come in. How do you analyze it? What parts of that data? What timeline? What pieces of information you're trying to connect, and how do you act on it? That's all the smart stuff, right? So for 24, why do businesses and scientists attempt to analyze it? To gain insights smaller subsets of data may not provide. Well, that's true, right? If they've got smaller subsets of data, why use big data? Or it's because sometimes small subsets of data won't show you enough information. So A is kind of looking as one reason. B, to confirm the findings from smaller data sets. That's not the main reason. It could be the case that they would look at a larger bunch of data to kind of corroborate some of those trends, but that's not the main reason. To identify potential problems in the metadata. No, I'm not really feeling that. Metadata, data about data. And D, to obtain economies of scale with hardware needed to store the data based on Moore's law. Here they're just bunching up a group of different computer science terms, right? So economies of scale is a business term that when you buy more, generally each unit gets cheaper. And Moore's law is about computing power doubling every 1.5 to 2 years, and also the size of it shrinking as well. So it's really A, to gain insights that smaller subsets of data may not provide. That was 24. Okay, for 25, how do the World Wide Web and the internet work together? So they perform the same functionality? Not really. The World Wide Web is kind of like this intangible. It's almost like an application that uses certain protocols to move files around, whereas the internet is physical cabling, routers, devices that are on that network, whereas this is more like the application side, the intangible part of it. So B, the web uses HTTP to share computational artifacts using the internet, Well, that's true. Computational artifacts can be anything from an image to a document to a video. So that's true. Let's take a look at, and because it's an application, it's using that protocol. C, the internet uses the web to connect devices to share data. So again, the World Wide Web is more that application. It's not like the internet is necessarily using it. It's just the web is on top of these physical connections, the cables, the routers, servers, etc. So I'm not really feeling C. And D, the internet has the deep net and the dark net, but the web does not. Again, they're throwing in some terms here just to kind of make you think that it feels good, but B is the answer for 25. Just remember the web is, the World Wide Web, or the web is using this protocol HTTP, and it shares packets, which themselves are bits, binary digits, and they make up the artifacts, which computational artifacts, which are images, documents, websites, movies, all that other stuff. So 25 is the answer there. Okay, moving up to the top right, this is number 26. If a fire occurs at a major internet hub, what is the result? So A, internet traffic will be routed to its destination in a different way. Well, that's true because of the redundancy built into the internet. That is true. If there is a fire at a major internet hub, the whole internet should not go down. There is redundancy built in, meaning that if things on a network have to try and connect, have to go from here to here, and something breaks in the middle, there's redundancy, meaning it can be rerouted and still get to its same destination. So A is going to be the answer here. For 27, in the following web address, how many domain levels are there? That's for 27. So how many domain levels are there? Okay, so the main domain is this, anyplace.edu, anyplace.edu, that's the domain name. And then we have a subdomain, and then another subdomain here, and then you have some folders. So the answer here is that the domain levels go from the TLD, the top level domain, which is this is the TLD, to the left. So we focus here. Now that could be .com as well, or it could be .net or .org or .nyc. It could be any of these things, and then we count going to the left. So any place is going to be the second. This is the second level. This would be the third level, which would be that first subdomain, and then any time is the fourth. And it's very unusual to see a URL where we have this many dots in it, but this is going to be 4 levels, so C is going to be the answer. Okay, 28. So if a company is trying to determine whether to upgrade its bandwidth based on the following graph, what should they measure? So just taking a quick look at the graph, we've got data utilization. The top line is how much data is downloaded. The bottom line is how much data is uploaded. So when you connect to a website and you're browsing, you are downloading information. You're downloading the images, the video. If you're streaming video, you're definitely downloading. If you're sending an email, you're uploading. If you type in a web address, then you are sending a very small amount of traffic when you type in that domain name for it to go to the website, and then everything that's being returned is being downloaded. So here we see megabits per second on the y-axis, and we see a bunch of A's and P's at the bottom, right? And then bandwidth purchased. So it says if a company is trying to determine whether to upgrade its bandwidth based on the following graph, what should they measure? So A is the amount of traffic or the amount of data uploaded as it includes strategic company backup data. So this is making you think like security of backup data. But what should they measure? Should they measure that? If they're thinking about upgrading the bandwidth, the upgrade, the bottom line for data upload for the bottom line is not very high at all. So their problem is not uploading data. So B, the amount of data downloaded as it has the largest impact on the bandwidth. That is definitely correct. Okay, frequency of the peak times, so how often they have those peak times, that seems like it's important. And D, the type of devices that employees use on the network. That isn't directly linked to the bandwidth, the type of devices. They could be using a phone, a smartwatch, a laptop, a smart TV. You know, that D doesn't really make sense. The frequency of the peak times, you know, it's more, the bandwidth represents like almost like a pipe and how big the pipe is to deliver the internet. So knowing the peak times is important, but more so knowing what's happening at those peak times, like what is the level at the peak times is even more important. But out of all of these, B stands out as the amount of data downloaded, as it has the largest impact on bandwidth, is the correct answer. Okay, for 29, why is the trust model of the internet important? Okay, so the trust model is basically when you type in a website, you expect to get that website. You know, if somebody was able to hack a DNS server and direct traffic to a fake Amazon and take your credit card and take your order and make it look like Amazon, that would be a problem, right? So they generally have certificates on websites that are kind of authenticated so that you know that the website is legitimate. So why is the trust model of the internet important? A, it ensures private security key has not been compromised. That is not correct. B, it establishes a dedicated line between two destinations. That's not how the internet works, right? Like this might be your origin, this might be a destination, but you might go different ways to that destination. You might come up here, down there, and back. So it's not just, you know, that single dedicated line. Okay, for C, for 29, it enables the secure transfer of data, such as a credit card transaction, which allows online purchasing. So when you go to a website, you really expect it to have that little padlock in the top left corner, so that there is SSL that is on the website, and maybe it also shows that there's a certificate, right? And so it's really important to do that mainly for sending this sensitive information, right? Online purchasing, credit cards, all of that other stuff. D says it ensures the privacy of customers making online transactions. That's actually more of the SSL to encrypt that traffic. But C is very important because this is relating directly to the certificate or authorities. And the notes here say that so that customers that confirm ownership of their encrypted keys with secure internet communications. So this enables us to have online shopping and other secure online transactions. So mainly for those transactions is this important. You know, it's less about privacy and it's more about protecting credit cards, transactions, shopping, all that other stuff. Okay, for number 30, it says what happens in a DDoS attack. So this is a distributive denial of service attack. And so generally what happens is every device has like an IP address, like a set of numbers that connects it to the internet. Now, if from the outside I try and connect to it, but let's say that I connect to it 1,000 times, or I try and do this like 1,000,000 times, or 1,000,000 times a second, 1,000,000 times like a fraction of a second, that's then gonna stop the internet service from working to this device, and it's gonna start going offline. So that's the key thing, is to get the thing offline. So bots search for malware detecting software that prevents uploading with, no, it's nothing to do with those things. It's not about necessarily malware. Okay, B, firewalls are deactivated. Is that malware? Nope, not true. The targeted site is flooded with too many requests and then crashes. That's it. Now here it's talking about a site, so the same kind of picture that I've drawn up here, where somebody does a DDoS attack on my computer and then the connection out might go or the connection in might go. It's the same if it's a website. This could just be a web server and somebody performing this attack, or maybe even many people from around the world coordinating, or software from around the world coordinating to do this attack on a website would make the website crash. So DDoS attacks are to flood, that's a great word, to flood the site or the server with too many false requests, and then it crashes. Okay, it's not to do with D and encryption. Okay, number 31. So which option below is a potential negative result of storing data in the cloud? So the cloud itself is just a server that is not in your home, right? It's somewhere outside. So you might say photos in Google Photos or in iCloud, somewhere like that. So it could be storing photos, storing data, whatever it is. So here it's looking for a potential negative to doing that. So let's go through them. It says A, you have to rely on someone else to maintain the security of the data. Well, that's kind of true, right? Like if your photos are in the cloud, like what's to stop other people from getting access to them? Well, that would be your passwords and security, but you don't manage that. You might have set a password, but you're not really managing that. So A would be the answer. That is a big potential negative. If you wanted to check the others, online collaboration would result in accidentally, or could result in accidentally overriding someone's changes to a document. That could be true. Online collaboration could result. But that's not always a negative, right? Like it might be something that you want. You might want somebody to overwrite or to edit a document as well. C, you must store duplicates of data stored in the cloud in case, like you don't have to do that. You could just leave it in the cloud. Usually there's backup mechanisms there in the cloud as well. And then D, the company storing your data could hold it for ransom until you pay extra fees. Well, you know, unlikely to happen, but that itself is not a negative of storing data in the cloud. When you think about it, just if storing data in the cloud works perfectly, it's looking for a negative then. And there are negatives. Even if it's working perfectly as intended, you still have this problem where you are relying on somebody else to maintain the security of that data. So still, you know, in some of these questions, there is a little bit of vagueness. So we're just always looking for that best answer. Okay, so 32, if an organization wants to change its website from an org to a edu, so again, these are TLDs, what do they need to do to ensure that it can still be found on the web? So it says that they must register the name with a DNS, a domain name system site. Well, yeah, like once you buy the domain name, you have to change the name servers, right? You have to change the DNS on there to point it to the IP address where the website files are being hosted. So that's really important that they do that. They can't start using it immediately because they could start doing it, but that's not a way for it to be found on the web just because they're using it. You need to point the domain name servers to it. Notify the IETF, the organization that maintains the names on the internet. Technically, that's not correct. Like ICANN, ICANN, are the organization for the internet, something, names and numbers, right? So this is the organization that when you register a domain name, they get notified, and they are kind of in charge of the naming and numbering system on the web. And then post the new name of the organization on the website up to 10 days. This is like a little silly. It's like, why? Like, just doesn't make sense. So A is your answer for number 32. Okay, jumping up to the top right, 33, which of the following is true about packets? So packets are bits of information that get sent from a computer and received to a computer. If you're sending a photo or any kind of a file, this will get broken up into many different packets that then travel. And the same when you receive them, or if you're streaming, packets will come back. But they all get the file gets broken up on the way out into smaller packets with, you know, that made up of ones and zeros as well. And the same when they get received, they're all broken up and then they get put back together. So for 33, it says, which of the following is true? So A says the receiving device acknowledges the first and last packets to indicate receipt of the data stream. All right, so part of that sounds good. So then B, packets travel in order to their destination. That's not true. Sometimes you can have different packets overtaking and undertaking, and that can happen. They all get put back together at the end, but they don't have to go in order because they could be going through different routes, right? You could have packets going in a different order this way. Okay, for C, packets follow the shortest path to their destination. Like they might attempt that, but it's not always true, right? Because sometimes, it's quicker if you have 1,000 packets to break them up and send them in different directions sometimes than sending all 1,000 straight through. Okay, packets are reassembled at their final destination. That is true. So even if they're out of order, they all get put back together in the correct order. So D is the answer for 33. For 34 over here, it says, how do TCP and IP interact? Okay, so IP is Internet Protocol, and that is the numbering system, almost like a telephone number on the web. It's a series of digits and dots. And if there's, every device connected to the internet has an IP address. And then TCP is the system, the transfer protocol that creates packets and manages the control of them. IP is the thing that routes them to their final destination through different points, different nodes on the internet. So as we look through all of these, C is going to be the closest to that. So TCP creates the packets from the data to be sent and transfers the control to the IP for routing. So IP is all about that numbering system and sending them in a certain direction. And then at the other end, TCP then reassembles those packets at the destination. So C is the answer for that. 35 is talking about data mining. So data mining allows organizations to process huge data sets to find new patterns, connections, or opportunities. Which of the following is not a downside of data mining? So we're looking for not a downside. So everything else, 3 of these should be a downside. So it may require having to train staff and allocate resources based on the data results. Well, that is true, right? Depending on the results, you might have to allocate resources based on those results. That's true. Okay, B, more relevant information is included on the company's website. Like, what? Like, that just doesn't really make any sense in terms of data mining. So that is not a downside of data mining. It is expensive to collect, store, and process data. That is true, right? They got to pay for storage and to process it. And then D, it is risky for decision making if the data is interpreted incorrectly. So they have to be careful that when they look at all of the data that they're mining, that they do the right thing with it. So those can all be downsides, but B, something about including it on the company's website does not make sense. Okay, 36. Computers have enabled new innovations in a variety of industries. In the entertainment business, it has become much easier to purchase and share new music. What concern has been raised as a result? Okay, so because it's easier to buy and to share music, there can be a problem with people sharing that music and maybe not always paying for it, right? So let's take a look. People are modifying other people's content and claiming the Creative Commons licensing allows to. Well, first of all, Creative Commons, if you come up with a piece of work, you write a song, make some code, draw a picture, whatever it is, and you launch it with the Creative Commons license, that means that you allow anybody to go use it. And they don't even have to get your permission. So anyone can use it. But the only stipulation on it is that they give you credit. So they must give you credit for being the person who originally built it. And with Creative Commons, you're allowed to modify. So if they claim the Creative Commons, you can modify other people's work. So this one is kind of a little, it's disconnected, but there's a contradiction here because you are allowed to modify with Creative Commons. So it's not that. So for B, for 36, it says people are being discovered for their music because others are posting it and sharing it. That isn't really a concern that has been raised. I think people like to discover other artists by, for example, going to YouTube or Spotify and listening to music that is being shared in that way. And this doesn't really talk to the point about permission, right? So this one doesn't really feel too good. For C, for 36, it says people are sharing content without the author's or owner's permission. Well, if it's being shared without the permission, this is a problem. And this is one of the concerns that's been raised, okay? And this goes back to when Napster was around and people were sharing music illegally in that way. Lots of people were. And, you know, that was right after, you know, we had tapes then, or records originally that turned into tapes as a medium to keep music. And then the tapes were converted to CDs. So you could get a lot of songs on a CD. And then everything became digitized. So that's when it became very easy to share those files. And so sharing without the author's or owner's permission is very, very important. And the difference between an author and an owner, the author could be the songwriter, the owner could be the record label who owns the works of that author. And D, artists are adding their music to streaming services. If that's happening, then they're choosing to do that. It's not a problem. No problem there. All right, so that was 36. Scooting over to 37. So here it's talking about the Dmca, which stands for the Digital Millennium Copyright Act. So which of the following are legal and ethical concerns because of Dmca? So peer-to-peer networks used for illegal file sharing. This is a huge problem. And this is what I was talking about with Napster. It was peer-to-peer is where you don't have all of these files on a website that people are connecting to with their laptops. It's not, this isn't happening. The website is not even part of it. You have people with files saved on their laptops that are sharing directly between each other and to other laptops that are, or desktops that are out there on the web. And so this is the peer-to-peer network. This is definitely, I would even say, the main concern that the Dmca kind of got involved because of. Okay, so for 38, what is the benefit of the government posting databases for public use? Okay, so for example, you can search a database that's publicly available in New York City to find everybody who got parking tickets in Flushing, Queens. You can do that. You can find out how many car accidents there were, you know, like a month ago on Tuesday. You can do that. So what is the benefit of the government putting out these databases there, right? Why would they do that? So it's a way to identify the need for new policies and regulations. Like publishing it isn't necessarily gonna like identify the need unless people are looking at the database and people who aren't employed by the government are creating solutions based on that data. So this one doesn't really feel so great. For B, consumers can learn more about how their individual data is being collected, stored, and used. There shouldn't be anything personal in these databases. Now you could argue if it's showing the license plate of a car that had a ticket, that is kind of personal, but it shouldn't really be private databases that connect to your name or even your address really. Now if you've applied for a license, maybe you've applied for a license for a beauty salon or something, then in that case, maybe the address is going to be used. But in this case, B isn't ideal. Okay, so C for 38 says companies can opt out to prevent competitors from learning about their businesses. Well, you know, if those are publicly available databases, a company's not going to be able to opt out. If they've applied for a license or some kind of permit to do an extension of their business, or let's say that they're serving food and they got a bad rating, then they definitely cannot opt out of that. And then D, all businesses can access the data at no cost, aiding those businesses that would otherwise not have the resources to obtain the data on their own. Okay, I think that this is, maybe this is a bigger deal than what I thought. It seems like it's a weak connection, that the benefit of a government posting these databases for public use is to help businesses that can't, collect the data on their own. It definitely is a benefit. I kind of also think, though, that just having that data out there helps people kind of like come up with some interesting civic solutions to some issues that are going on, especially in big cities. But out of all of them, small businesses and large businesses getting equal access to this information in the databases is definitely valuable. Okay, for 39, says which algorithm will display the smallest number in a list of positive numbers. And it says assume that max is a variable holding the largest number in the list. Okay, so then we have like a whole bunch of answers here. So we want to find out which algorithm displays the smallest number in a list of positive numbers, and that max is a variable holding the largest number. Okay, so if we look at A, let's figure out what A does. So it assigns the smallest, it assigns as -1, right? And it says for each number in a list, so for each num in a list called list, it says if the smallest, which at the start is -1, is less than num, then the smallest becomes num. So if the smallest is less than num, right? Now it does say that the list is of positive numbers. So if the smallest is less than it, then the smallest becomes num, and then it displays the smallest. So let's think, if we have a list of, let's say, 1, 2, 3, and so on, and then for each number in list, it checks this. So at the moment, 1 would go right here, and it says if smallest is less than num, and that's 1, then the smallest becomes 1, and then it displays the smallest 1. Now, this would only work if this list is in order from smallest to largest, and then it's just always going to print that first number. It's always going to display that first number. So that's like a little weird, right? And then also it says assume max is a variable holding the largest number. Now max is not being used in A. Max is not used right here, so therefore A is definitely not looking good for a couple of reasons. All right, B says smallest is assigned max, and then it says for each number in list if smallest is greater than the num. So assume max is a variable holding the largest number in the list. All right, so if the list again is 1, 2, 3, and really set notation, we should do that. So in this case, max would be 3 because it's saying that max is a variable holding the largest number in the list. That's what it says right up here, largest number in the list. So for each number in the list, if smallest is greater than num. So even if this list is all mixed up, let me just scroll down a little. And this is why it's important, because just like I ruled out A, I said, well, what happens if they're in a messed up order, right? So here, if smallest contains the largest number in the list, which is weird, but smallest is assigned max, which is, in this case, is 3. It says for each number in the list, check if smallest, which was 3, is greater than num. So at the beginning, because it says for each num, that means 1 goes in there. And it says if 3 is greater than num, if that's true, then the smallest, which was 3, becomes that num, which is now 1, right? And then it does this from here to here. It does everything here for each of those numbers. So it goes through everything. So the first time it checks 3 is greater than 1, and then the smallest becomes 1, so that becomes 1 over there. And then while this is 1, it checks if 1 is greater than, and now the next number would be 3. If 1 is greater than 3, the smallest now becomes the 3, but it's not. 1 is not greater than 3, so the smallest stays as 1. and then it goes up to the top again, and now it's going to try 2. It says if 1 is greater than 2, then that 1 would become the 2, but it's not greater than 2, so it stays as 1, and it displays the smallest, which would be 1. So because we want which algorithm displays the smallest number in the list, that's exactly how this one works. It's a little tricky, but try and rewind and listen again and see if you can see it. But one of the key steps here is that we don't know that the list is in order. So it could be 3, 2, 1. It could be something like this, or it could definitely have many more numbers in there and decimals. It could have a lot of stuff in there. But B just makes sense for this. Okay, so that was 39. Let's take a look at 40. So 40 says, for a binary search to produce accurate results, what must be true of the data? Okay, so this is question 40. So the data must be unsorted. Well, that would mean that it's just random, right? But that's not true. For a binary search to work, and remember what this means, right? Like a binary search is where, if you imagine a telephone book, that's got like 1,000 pages. Now, if we open it and we get to the letter M and we're looking for like Steve, right? Or let's say last name was Stevens, then we know that we can ignore, like if we get to halfway, we know that we can ignore half the book. And then we could split this in half. And then we can see, all right, we got to look to the left of that, and there's about 250 pages there. And then we can know, oh, we got to look to the right of that. So binary search is where we take a long list, and when we're trying to find that item, we very quickly discard half of what we're looking at. And then after we've discarded half, we'll have the rest in front, and we'll know how to break that in half to look like to get closer and closer to our answer. Now, because we're discarding half of the list, we need to know that they're in order, which means that they must be sorted. If they're not sorted and they're just done randomly, then a binary search is just never going to give you the right thing. You're constantly going to discard what you're looking for. So for 40, B is the answer. It must be a sorted list of data. Okay, so for 41, it says, which of these is a Boolean expression? So here, this is just saying that X is being assigned 57. That's not true or false. It's not. It's just being given that value. And with Boolean, we're looking for something that is true or false. Here, the Y is just assigned some value, so it's not B as well. Here, temp is greater than 32. That is either true or false. It can be nothing else. So C is the answer. 42. What can be determined from the following? Program flow. Okay, so we've got these are all procedures right here. Procedure, 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 procedure. You can think of these as functions. So the intro thing happens, the rules thing happen, the play thing happens, the score happens, and then it displays the result of this function, high score. So it says what can be determined from the following program flow. So A, it says a game is played by calling the different the different procedures. That is kind of like the only thing that we know, right? Like if this is the game, it's definitely calling this procedure. It calls this procedure. It calls them, and even this is the display procedure, right? It's just displaying the result of this other procedure. So the game is played by calling different procedures. Yep, that's the only thing that we know. In terms of B, an error will occur. No, it's got nothing to do with the procedure names. C, parameters are missing. You can have missing parameters. It's still a call to the function. You don't always need a parameter. D, a compile time error occurs due to the score. They're just making this stuff up. It doesn't mean anything. They're trying to confuse us. So nope, nope, nope. The answer is A. Okay, 43. Which statement's format is incorrect? Okay, so, all right, so this is actually one long thing right here. All right, so this is like one long piece of code and we got to look through it. So it says, if this is not true, then display this. Now, Sometimes it will just keep going, and sometimes it will have an else statement here. And if it has an else, then if this is not true, if this whole thing here is false, then it would do the else, and that could be like a bunch of stuff down here. But in this case, it says if, then it will do it. If it's not true, it does nothing above there, and then it keeps going because of sequencing. It would now do this, and then it would now assign this. And here the problem is that we're starting with an else, and that is not allowed unless right before it there was an if. And there isn't an if right before it. So therefore D is the answer. This format is incorrect. It would need to be if something is true, then do this, whatever it is, else do this. That's the format how it has to be. You can't have these couple of extra things right here. It's not allowed. So 43 is D. Okay, scrolling across and to the left, 44 says which algorithm should be used to find a phone number on a contact list. Okay, so think about a list where we have names and we have numbers. So we have two things. We have 1 and 2 or I and then II. So for I, it says sort the contact list by name, okay, and then search for the phone number using a binary search. Well, if we did that, if we sorted it by name, we would have to search for the contact by name because it's ordered or it's sorted by name. We can't sort by name and then do a binary search for the phone number because the numbers are not in order. The numbers are all kind of randomized, right? Because everything's sorted by name. And just because your name is Adam doesn't mean that your telephone number is a super low number. And if your name is Zane, you have a super high telephone number. So numbers do not correlate with our names. So 1 is not good. That is not the right way to do it. 2 says sort the contact list by area code and then search for the phone number using a linear search and then display the correct number. All right, so this seems like it's like a really weird way to do it, but it could work because if you've got everything by area code, so you've got 718, 718, whatever it is, and then maybe you've got 719s wherever this is, and then 720, and then a 918. If you've got everything in this order, and then you are searching for the phone number using a linear search, it means that you can go through them and be like, okay, it isn't that one, it isn't that one, it isn't that one, yes, it's this one. Now, it's still not like, it is still not super efficient, you know. It would, if you're searching for a number, you know, you generally when you search for a number on your phone or in your contact list, you'll kind of have an alphabetized list of people, and then you search, you do kind of some kind of like a binary search for their names, right? You kind of like go halfway through, or you go to the end because you know that their name's closer to the end of the alphabet, and then you find their number. But because I doesn't work, like number 1 up here does not work, because the binary search, after you've not got them by number, you're doing a binary search of a phone number, even though they're sorted by name. That's just wrong. It's just not going to work out. 2, say sort them by area code and then search for the phone number using a linear search. So yeah, it's still a little weird because it might take you a long time to get to the number, especially if they're 918 and you have like 1,000 718s, but it will still get you the right answer. So it says, for answer, the question itself up here was which algorithm should be used to find a phone number on a contact list. So because it's not 1, it has to be 2, even though it doesn't seem like it's the most efficient way of doing it. So when I look through this, you definitely shouldn't do a combination of both because 1 does not work, and so this doesn't work and not a combination. So reluctantly, the answer is going to be B for question 44. Yeah. So of these 2 algorithms, number 2 is more effective, even though there's probably a more efficient way to do it. Okay, number 45 here says, why does a computer playing chess use a heuristic algorithm? So this phrase here, heuristic, super important. This method is more talking about like a rule of thumb. It's when an exact answer cannot be determined, right? Sometimes a computer can do a calculation, run a procedure or a function, and deliver an exact answer. For example, it can find, like how many people are on a list. It can use computer vision and count objects in a room. Although even then, depending on what it's counting exactly, it might be accurate depending on how those things are being tagged. But in this case, a heuristic algorithm being a general rule of thumb kind of makes sense with chess, right? It makes sense with chess because if it is analyzing every single move that can be made on the third move and the fourth move and the fifth move, if it's doing every single move, we're talking like, gosh, millions and billions of possibilities to travel through a game and for it to play every option of a chess game, for it to think about the outcomes of that when they're playing somebody else who also has the option to do an infinite number of moves almost. So looking through all of these answers, it ensures a computer only wins a certain number of times, making it more experienced. No, that's not what this algorithm is. It's not like somebody letting somebody else win. That just doesn't make sense, right? B, it ensures that humans only win a certain percentage based on statistics. No, it's got nothing to do with letting humans win or humans winning a certain percentage, right? C, it takes too long to analyze all the possible moves, so the computer takes the next best move. Yeah, so it kind of like comes up with a list and then makes the next best move, right? So C is going to be the answer because, like it says, it takes too long to analyze all the moves. D, it checks each possible combination of moves for the best. So it runs out. There's just way too many moves. It can't go through all of them. Okay, so that was 45. 46 is up here. It says, what does iteration with computer science loop means? So iteration means to repeat. So a loop will repeat until a condition is met and then it ends. So what does iteration mean with computer science loops? What does iteration with computer science loops means? So it means that it will repeat something until a condition is met. So B is going to be the answer. Okay, so it's like, and if something is true, do this, right? Yeah, or while something is not true, then do this. So that is 46. 47. So here we've got a list named snacks, and it contains the values of chocolate, peanuts, granola, chips, grapes. So chocolates, peanuts, granola, chips. I'm going to do a CP there, and then GR for grapes, to not get mixed up with granola. All right, don't think that's going to help me too much. So it says, what will the value of snacks place contain? So let's think about this. So as we read it, snacks is assigned those values, and then a variable place is assigned this value. So a variable called place is assigned the length of snacks. So for this one, we have to think, well, what does this mean, length of snacks? Well, we've got 1, 2, 3, 4, 5. So this means that place is assigned 5. 5, because the length of snacks is 5. So if place is assigned 5, and then it says, what will the value of snacks place contain? Well, place is 5. So really, we're looking at snacks 5. And what this means is, what is the 5th item of that list, of the list snacks? So the 5th item of the list of snacks is, well, this is the first, this is the second, third, fourth, fifth. So snacks 5 is going to return grapes. So it says C, grapes, which is the value in the 5th position of the list. So C is the answer for 47. Okay, 48. Will both of the following blocks produce correct results. Assume all variables have been properly initialized. All right, so here are the two blocks below, and it wants to know if they'll produce the same or produce correct results. All right, so let's take a look at it. And just a reminder, this is number 48. So if the temperature is greater than or equal to 80, hot day is assigned whatever hot day is plus 1. Okay, so I guess this is counting the hot days, right? Hot days. So if it's more than or equal to 80, it does a plus 1 on the hot day list, right? It's assigned whatever the value was plus 1. Okay, else if temperature is greater than or equal to 60, so that means if it's from 60 to 79.999, right? Then it goes to perfect day. And perfect day is assigned whatever the perfect day is plus 1. So however many it was, plus 1. If that's not true, which means that the temperature must be less than 60, it says cold day, and then that ends up with a plus 1. So that's the behavior of block 1. With block 2, it says if the temperature is less than or equal to 80, then perfect day is assigned perfect day plus 1. Well, this is kind of a problem because if the temperature is 0 degrees, that is less than or equal to 80. So that's going to give perfect day plus 1. And then it says else if temperature, and this doesn't really work because here, this could be true at 0 degrees, so then this would run. This would not run because it already did the first thing in the if. So when an if is performed, it doesn't do the else if. So therefore, block 1 does what's intended. Block 2 doesn't. So only block 1 is correct. So that's going to be A for 48. All right, we are getting there. Number 49. So determining that an algorithm is intractable means it runs in. So now we've got to think about what intractable means. So intractable algorithms are not efficient for large data sets. That's what it really means. So keep in mind this is like the vocab word. So it means it's not efficient for large data sets. So as we go through this, an acceptable amount of time, even for large data, that is not true. Less time for worst case scenarios than average. That doesn't make sense. Okay, C, an exponential amount of time, possibly even for small data sets, making it unable to run for large data sets. Yeah, so it does not run efficiently for large data sets. Here it's a little confusing because it's talking about an exponential amount of time, possibly for even small data sets. That makes you think, well, how could that be? But the key thing is that it's unable to run for large data sets. It just makes it almost like impossible for that. So that is C. Okay, D, a fractional amount of time for fractional. Doesn't make sense. It's not going to be that. Okay, so for 49, it is C. For 50, which order has the programming languages in most abstract to least abstract order? So remember, abstracted languages are higher order, higher abstraction. Least abstracted is low level. Low level is closer to computer language. It's not readable. Abstracted or higher level languages are readable, and it's closer. Readable is closer to natural language. Okay, so it wants least. It wants from most abstract to least abstract. So text-based language, assembly language. So assembly is pretty low down on the level. And this one's most abstract. So when it says most abstract, we're really looking for things like Scratch or Snap. That's what we're looking for, which are the block-based languages. So for highest level, I see for B, it's got block-based language first. I like that. I see for D, it's got block-based language first as well. So it's not going to be C and it's not going to be A. And then, you know, like I've got down here, the least abstract is more closest to computer language, which is low level and not readable. So that would be the machine language. So the machine language is kind of like closest to the ones and zeros, right? On the very close to how the chip is processing this stuff. And then just to make sure, this one here says assembly language, which should be switched with machine language right there. And then text-based language is very close to block-based, but block-based is first. So this goes from highest to lowest level languages. So D is the answer for number 50. Okay, 51 says, which type of programming statement includes Boolean conditions? So those are true and false. Booleans, remember, true and false, to determine the section of the code to execute. Okay, so that's where it decides, do I do this or do I do that? And that is selection, and we see that in flowcharts as well. Okay, so in flowcharts, we'll often see a diamond where it says if something is true, or if something, then it will go over here. Else, so this is if true, else it will do something else, right? So selection is when it's talking about Boolean conditions, so it's 51. All right, 52, all the way over here, up on the right, top right, says which set of code will calculate the letter grade correctly. Assume that the average is a variable holding the student average. All right, so for 52, it says, for A, it says if average is greater than 59, make it a D. Well, already I don't like this, because what happens if the average is 99? That's greater than 59, and that student's going to get a D. So don't like A. Okay, for B, it says if the average is less than 59, get a D. All right, so if less than 59 is the lowest grade level, then that could work. And then it says else, so if it's not 59, if it's not less than 59, then if the grade is less than 69, which really means a 59 to 69, but not including either of those numbers, then they get a C. Else, if the grade is less than 79, which really means between 69 and 79, then get a B. Else, if the grade is less than an 89, which now means between a 79 and an 89, they're going to get an A. Else, they're going to get an F. Well, this almost worked, but if they've got a 90% average, it would have escaped all of these conditionals, got to here, and then it would be part of the else, so it would be given a 90% student an F, which does not make sense, so it cannot be the answer. So I'm still scrolling down. C is over here on the left. So it says if the average is greater than a 90, give them an A. Else, if the average is greater than an 80, give them a B. Well, that makes sense, right? Because if it's more than a 90, they would have got their A, and then the code would stop. But because if it's not, then it would go to the else. It would check if it's more than 80, then give them a B if it is. Else, it would check if the grade is less than 70. So this right here, got to be a little careful about, because 90 plus would get the A. 80 plus they wouldn't have already got the A, so they would be passed here, and that would give you a B. And now it's checking if the grade is less than 70 for a C. So that doesn't make sense. It should check if it's more, so it cannot be this answer as well. So it must be D. At this point, running out of time, I would box it up and just move on. But let's check. It says if the average is greater than an 89, give them an A. Else, if the average is greater than a 79, give them a B. Else, if the grade is, let's just check here, if the grade is less than 69, got to be very careful here. because even this is looking a little freaky right now. So average is greater than 89, give them an A. Right, that makes sense. Else, if now this is all indented, so we have to make sure that we're understanding where this else stops. So this else is going to stop here. So if they do not get an A, then it does all of this code here. So it checks if it's above a 79 to give them a B. If that's not true, that they don't get a B, now it does this stuff. It checks if the grade is less than a 69, they get a C. Now, that makes me just think, though, what happens if it's between 69 and 79? Like, that's what the problem is here, right? So, if the grade is less than a 69, they get a C. Else, if the grade is less than 59, they get a D. Else, they get an F. So this one, like, it looks like this one's broken as well. So I'm just going to check. I'm going to go back up to the question for this one, but unless I'm doing something wrong, it looks like there's a problem with this question. So it says, which set of code will calculate the grade letter correctly? Assume that the average is a variable holding the student average. Okay, so greater than 59, get a D. Greater than 69, well, 99 breaks this, so it's definitely not that. That's what we said for B. If it's less than 59, get a D. Less than 69, get a C. Less than 79, get a B. Less than 89, get an A, else F. Well, a 90% gets you an F in that code, so that's wrong. Okay, this one up here, if the average is greater than 90, get an A. Makes sense. Else, if it's greater than 80, get a B. Makes sense. Else, if the grade is less than a 70, get a C. Well, what happens when it's between 70 and 80? That doesn't work. And then D, which I boxed up, says if the average is greater than 89, get an A. Makes sense. Else, if the grade is greater than a 79, get a B. That makes sense. Else, if the grade is less than a 69, get a C. So there is a problem with this question. I've gone through it quite carefully. So 52, I would just scratch it. This set of questions came from a textbook, and it's such a shame that there is a problem with it, but it does look like it's a damaged question. So let's just move on. Okay, so for 53, it says the code below is a robot algorithm. Which diagram matches the code? So what we've got is we've got two move forwards. So forward, forward. We've got a rotate left, which just turns it left. We've then got a move forward, move forward. We've got a rotate right. And then we've got a move forward and then rotate left. So it does this. Moves forward, goes up 2, and moves across. So if it starts here, let's see, does A match it? This is 53. So it moves forward, turns, goes up, moves forward, and then no, it's still in this cell. This one would end up here pointing upwards like this. So let's try B. So it moves over 1. Now already I don't like this because at the end it looks like it's pointing in this direction, so it cannot be B because it needs to be pointing to the right. And it's also, if we count it, this is a good way to look at it. Wherever it starts, it moves 2 boxes over, 2 boxes up. And it is pointing up. 2 boxes to the right, 2 boxes up, pointing up. So 2 boxes over. But we do have to be careful because here it is starting by pointing up, which is a little confusing. Here it's starting by pointing down, so we've got to be a little careful with what we said here. So let's go through it. So definitely not A and B because they both start pointing to the right, so that little picture should work. So let's try C with the 2 move forward and a rotate left. So move forward, move forward, move forward, rotate left, points it to the outside, and then move forward, rotate right. So it's going to move forward, rotate right, and then it moves forward and rotates left. So then it moves forward and then rotates left. So it's definitely not C. So far, just like the last question, I canceled the main job with D, but let's check. So start to end, let's see if this works. So we got move forward, rotate left. So move forward, rotate left. And then it was move forward, rotate right. Right, so move forward, left, move forward, right, and then move forward and rotate left. So move forward, it's here, rotate left would be there. D is your answer for 53. Okay, 54. What benefit does an API provide? So an API stands for Application Programming Interface. And so you can build a website, maybe you're building a website about the weather, and maybe you want it to update automatically what the weather is in every city around the world. Now, because there's other websites out there and other servers that are tracking that information, that are storing it, you couldn't possibly, like, maybe you could, but like for you to go out there and put sensors in every city and then have your website connect to it, that just seems like it's a lot of work, and things are probably going to go bad, right? Like sensors will break, and how can you manage it? All of this other stuff. Well, if there is a service out there that is funded, maybe by the government or by a big business, and they're collecting this information, this data, and they're doing it very regularly in real time, if they allow you to connect to their server to retrieve that information, you can do that automatically and present that information on your website. So that's what APIs are really for. It's for connecting to data and services that provide extra information or functionality that you otherwise couldn't get. So for 54, it says benefits of an API. It allows programmers to share their code. It's not about sharing the code. B, it connects software components providing pre-written and tested code available for use. Yeah, it's kind of like a little weirdly worded. It sounds different to what I said, but it does connect your software to their software. So it connects software components. There is pre-written and tested code that's available for use, and then it returns you the data, right? Or it gives you this functionality. But B is the answer because it is about connecting software components together to retrieve that data, though. So this is really like the prize. It's really like, why do you connect to the API? For C, provides algorithms for different code to be reviewed. It's a little weird, reviewed. D, it provides documentation for programmers rather than creating their own. It's not just that there is documentation with an API. It tells you how to connect. How do you get your software to connect and authenticate and retrieve the correct things? But it is, so it says programmers can use for their programs rather than creating their own. They have to create their own software to connect to the API, but it's not, and it does save them some efficiencies if they can retrieve that data, but this doesn't really hit the point as well as B does. So B is the answer for 54. Okay, 55, we're given a procedure. The procedure is called calctemp, so I'm assuming this is named this because it calculates the temperature. And it says, what is the value of x after the code below runs? So procedure is called calctemp. Temp is one of the parameters that goes into calctemp. And it says new temp equals 5/9 times by the temperature minus 32. So this already looks like it is converting Fahrenheit and Celsius. That's what it's doing. So here it is assigning x the value of calctemp 50. So calctemp is the function. Here it's putting 50 inside. So then the new temp is going to be 5/9 times by temp minus 32. Well, that's 50 minus 32. So 50 minus 32 is going to be 18. So this whole thing here becomes 5/9 times by 18. Well, this simplifies 9 into 9, 1, 9 into 18, 2, so this equals 10. So it returns new temp, which has just been assigned 10. So x has been assigned 10, which is the value of the new temp. So 55 is B. 56 over here says, what is the value of y after these following statements? So, what is the value of y? Okay, so x is assigned 10. Great. Now x, which was 10 from above, is now assigned whatever x is, 10 plus 4. So that means that x is being assigned 14. Then y is being assigned x, which is 14 mod 3. So mod is the result of a division. It's actually the remainder of a division. So if you do 14 over 3, you get that 3 goes into 14 4 times, which makes 12, but the remainder is 2. So here, 56B would be your answer. Yep. And then I guess these blocks are being used for another question. So let's go up to 57. 57 is over here on the right. It says, what is displayed after the following code runs? So x is assigned 10, y is 15, and z is assigned 20. So if I put those numbers in, we've got 10 here, 15 here, 15 for y again, 20 over here. So 10 less than 15, that is true, or 15 is greater than 20, which is false. It says if all of this, so now we need to think, is this true or false? Is it true or false, true or false? Well, with an or statement, only one of them needs to be true for the whole thing to be true. Well, the first part, x is less than y, is true, therefore this whole bubble is true. So when it says if this, if true, well, it is true, so it does this. It does not do this because it's true. So it displays x, and we know that x is 10, so it displays 10. A is the answer for 57. And when they're quick like this, you have to go quickly. You need to get those points really, really quick. For 58, it says, which of the following two algorithms produces the sum of the elements in the list? Okay, so the sum. We've got two algorithms below. We're looking for the sum. And it says, assume the list is initialized. So let's take a look. So again, we're thinking which of these blocks, block 1 or block 2, gives us the sum. So here it says x is assigned 1, sum is assigned 0. So we've got x and we've got sum. So to begin with, x is 1, sum is 0. Now it's going to repeat the length of sum list. Okay, it's going to repeat the length of list time. So the sum is going to be assigned whatever the sum is, so that's 0, plus whatever the value of x is. Right, so the sum is going to be assigned, whatever it is, which in this case is 0, plus whatever the x is, which is 1 in this case. So 0 plus 1, so this is going to give you 1. And then x is going to be assigned, well, x right now is 1, it's going to be assigned 1 plus 1, so x is now 2. Now, this is going to keep happening for as many items that are on this list. So if there's 4 items on the list, this is going to keep happening. Now, x is not necessarily whatever is on the list. X is here is just being given the value of 1, and then later on it becomes 1 plus 1, it becomes 2. And then after this, it's going to become 2 plus 1, so it's going to be 3. So this is going to go up 3, 4. The sum is just going to keep adding 1 to it, adding 1. So it's going to become 1 plus 1, which is 2, and then it's going to become 2 plus 1, which is 3. This is not finding the sum of all items on the list. That's not what's happening here. So if I scroll up just to double check, which of the following produces a sum? So A is not really... A, which is talking about block 1, is not really producing the sum. So block 1, not producing the sum. Blocks 1 and 2, nope, not producing. So it's either B or D. So let's see if block 2 does give us a sum. So X is assigned the length of the list. So if we keep our same example of 4, let's say that X is assigned 4. So we've got X and we've got sum. So and this is our number 4, we just made it up just so that we can visualize it. Sum is assigned 0. And now it says repeat X number of times. So it's going to repeat this 4 times in our example. It's going to take the sum, which is currently 0, right? And it's going to assign it with the value of sum plus the item on the list, which is in place number, let's see, so it says repeat X times. Well, that X is 4. So what it's going to do is going to add to the sum the 4th item of the list. Okay, so it goes from 0 to adding the value of the 4th item. Great. And then X becomes X minus 1. So X becomes, so that 4 becomes 4 minus 1. So 4 now becomes 3. So X is now 3. So then it says repeat 3 times. So after it's done the first loop, it's now saying repeat 3 times. So that is kind of like changed, right? And now it's going to go back in that. Now because X is 3, it's going to take the current sum, which changed to include the value of the last item on top. So it's no longer 0, it's whatever the 4th item was in our example. And then 3, and then it would add the value of the 3rd item. And then that would keep going on until it says repeat 0, because X keeps going down, it keeps decreasing by 1. So it looks like block 2 does work, even though this value for the repeat does change. It said repeat 4, and then repeat 3, and then repeat 2. So let's just go back up, 58. So for 58b, looks like it is the answer. It says that block 1 calculates the total of the list indices. Block 2 calculates the sum of the elements of the list. So the key thing here is when it's saying plus list X, this here is the value of that 4th item. It's not 4, it's the value of the 4th item. Whereas over here, it's adding X, which is just the index. It's like the position, it's adding 4. If they're looking at the 4th item, it's adding 4, which is not correct. All right, 59. 59 says, what will the following code produce? So let's take a look. X is assigned 5. Y is assigned whatever X is. Well, X is 5, so now Y is 5. They're both 5. And then X is assigned whatever Y is, which is 5 plus 5. So now X is 10. So X is 10 and Y is 5. So now it says repeat until X is greater than Y. So repeat until 10 is greater than Y. Well, Y is 5. So repeat until 10 is greater than 5. Well, this is true right now. 10 is greater than 5. So it doesn't do it. Doesn't do anything. So for 59, it says code inside the loop will never run because 10 is greater than 5 before the loop runs for the first time. So that gives us an answer of code inside the repeat until never executes, B. Okay, so 59 is B. Okay, so question 60, we are given this, where are we? Right here. We're given a list. The list is called snacks. We've got 1, 2, 3, 4 items on this list, and the code starts right here. It says for each snack in snacks. So these are the names, snack and snacks. The first thing after the for each represents an item, and then snacks is the list. So for each item in that list, if the snack does not equal banana, then add to snacks banana at the end, and then display the snack that was first asked for right here. And snack, remember, is the item on the list. And when it says for each, it goes through each and every item. So what will this code display? So for each snack on snacks, so it's going to test the first one, popcorn. So popcorn equals banana is false, and not false is true, so it's going to do this. Now, that might seem a little confusing, right? What I just said. So the first thing that it does is it tests if popcorn equals banana. Now that is not true. And usually if something that is not, if something that is false, that means that it does not do the thing inside. But because it says not, so this means when popcorn equals banana is false, that's false, popcorn does not equal banana, but because it says not, it turns that into a true, and it acts as though this is true. So if this is true, well, yeah, it is, then do this. It's going to add the word banana to the end. That's what we call append. It means add to the end. Add banana to the end, and then display snack, which was that first item. So it says popcorn. That's what it displays. Next, it's going to now check the next item, candy. So candy equals banana is false. It turns it to true because it's not, and then it appends banana on the end of the list. Now it already added banana at the end. Now it's going to add banana again, and then it's going to display snack. So it's going to display candy. Next, it puts in grapes. So grapes doesn't equal banana, so it adds again. It's going to add banana on the end of the list, and it's going to say grapes. Now the list is expanding every single time because banana keeps getting added. So now it's going to check apples. So we come here. Apples equals banana is false. Becomes true with that not. So then it adds the word banana again to the list, and then says the snack that was referenced, which was apples. So it's going to say apples. Next, banana is on the list. So it wasn't originally, but now it is. So now it's going to check if not banana equals banana. So banana equals banana is true. So when it does not that, so remember banana equals banana, that is true. If not true, so that would be false, right? So if not true, which is false, then it's not going to add the word banana, but it does display, it does say banana. Right, so even though it doesn't add another banana on the end here, it looks like it's stopped adding bananas, but it does say the word banana. And then we've got another banana, so it does the same, and then it displays banana at the end. And then it's got another banana, and it's basically got 4 of them. So there's 4 bananas at the end. So it says, what will the code display? Well, it's all of this stuff. It's all of this that it displays. So popcorn, candy, grapes, apples, followed by 4 bananas. So the answer for 60 is D. 61, which is right here, it says, what is the index position of apples? Well, apples is, let me just change over the color, make it super clear. We've got popcorn, candy, grapes, apples. So apples is in 4th place. So that's going to be the index of apples. That was a nice easy one. 61 is 4. Go back up to 62. 62 is over here. It says, what is the value of snacks after the following code is run? All right, so you've got to be a little careful. So, all right, this is new code, so it's not really referencing the old stuff from 61. Or is it? It says 60 to 62 refer to the following code. Well, let's see. So here, snacks is now given 1, 2, 3, 4, 5, 6, 7, 8. Snacks is given 8 things. And j is assigned the value of 1, and it says repeat until j equals 5, and then it stops. So snacks, at first snacks 1, which represents donut, is assigned j plus 4. Well, j is 1, so it looks like snacks 1, which is donut, is assigned 5. So this is just assigned the number 5. Next, after it assigns that, j becomes j plus 1. So now j equals 2. So now it's 2. So now it looks for, and it's going to keep repeating because it says repeat until j equals 5. Well, j is 2 right now. So now it looks at snacks 2, which is French fries, and it assigns to it 2 plus 4, which is 6. So this becomes 6. And then j becomes so that was 6, and then this becomes j, which is 2, becomes 2 plus 1, which is 3. So repeat until j equals 5. Well, now it's 3. So then it looks for snacks 3 and assigns it 3 plus 4. So this becomes 7. And then j, which is 3, becomes 3 plus 1. So j becomes 4. Then it looks at j4 and assigns that 4 plus 4. So this becomes 8. And then j, which is 4, becomes 4 plus 1, which is 5. And then 5 comes here, repeat until 5 equals 5. So it stops. Stops right here. And so as I'm looking at this right now, I see that these items have all been changed. 5, 6, 7, 8. Candy's still there. Grapes is still there. Apples is there. And banana's still there. Those changes were made because of this code right here. And it says, what is the value of snacks after the following code is run? So it's not talking about what's displayed. It just wants to know what's the value of snacks, which is a list. And so that's just everything inside it. 5, 6, 7, 8, and then candy, grapes, apples, and banana. Now, after we started getting the 5 and the 6, if you look down your answers, we see it's going to be A. So we should definitely try and take shortcuts with these, especially on the test when you only have the 2 hours for the 74 questions. You got to go real fast. So 62 was A. 63 right here says, what is displayed after the following code runs? So line 1 is assigned good luck. Line 2 on the exam. Line 3 says display line 1 plus line 2. So it is going to display good luck, and then it's going to have a space, and then on the AP exam it's going to display all of that stuff. So good luck on the AP exam. It's going to display B right here. It's not going to put a space or it's not going to put a line break there. It's going to display B. Okay, 64. What is an iterative software development process designed to do? So when you develop software, you write lines of code, then you got to test it. You got to find the errors by debugging, then you got to improve it, and then you got to retest it, and then find the errors, and you keep getting better and better and better. So for 64, to produce better software with a proven process. Yep. So iterative software development is proven. Keep repeating. That is the answer. It's A. So doesn't necessarily shorten the development time. You don't eliminate testing. Testing is a part of this process. And D, to develop it right the first time. No, nothing is ever perfect the first time. Okay, so that was 64. 65 is right here. The programmer tests an app she wrote using one set of test cases. Since the app was developed for her personal use, does it need to undergo further testing? All right, so let's think about this. The programmer tests an app she wrote using one of a set of test cases. Since the app was developed for her personal use, does it need to undergo further testing? So yes, all software should be tested with a variety of test cases to ensure the code works as expected. So this feels really, really good. It seems like reasonable to say that all software should be tested with a variety of test cases. The only thing is that it does say since the app was developed for her personal use. So if there is absolutely no chance that anybody else is going to use this and it's just for her, then it doesn't need to be tested with a variety of test use cases. It just needs to be tested with her, right? And so A is looking less likely if strictly it is just for her. Okay, B, no, since the app was for personal use, less stringent testing is acceptable. That is true. Let's just check the others. Additional testing is required only when there are more than 20. That doesn't make sense. It doesn't matter how many lines of code. What does 26 lines do to the 20? You know, just adding one more line, does that change anything? D, additional testing is needed when procedures are used. Again, that's like just throwing in a key term there to distract you. It doesn't matter if procedures are used or anything. So B is the correct answer there. Case 66 says, which set of code will move the robot from the start to the stop and facing the correct direction? The robot may not move into any of the gray blocks. All right, so A is right here. Let's test it. So A says move forward 1, 2, 3 times. So 1, 2, 3. Rotate left would be turning up like that. Move forward and rotate right. So move forward, rotate right. Move forward, rotate left. Move forward, rotate left. Move forward 3 times. 1, 2, 3. And then rotate left. And then move forward. It looks like the answer to this one is A. So 66 is A, yeah. Thankfully, we don't have to test these others because that would take a while. Okay, 67 says cloud-based data storage is best when what conditions are true of those working with the data. And it also says select 2 answers. So remember, when this is talking about data storage, cloud-based means that it's all online in the cloud. It's in data centers somewhere that multiple people around the world can access using any device. That's usually it, right? So it says that it works best when which conditions are true of those working with the data. So that when they are in a secured location, true of those working. So this is talking about the people working. So the people working with it need to be in a secure location? Not necessarily. When they are in separate locations, well, yeah, that makes sense. If they're all in the same location, then why put all the data online where it has to be reached and connected to? Why not just have a local server, in the office or whatever? So B makes sense, that if the people are in separate locations, it's much better for them to be in the cloud, for the data to be there. C, they are dealing with sensitive data. That's not necessarily true. Could be sensitive stuff in the cloud, or it could just be like non-sensitive data as well. So that doesn't really feel so good. And then D, they have limited storage at their location. Yeah, if you don't have a lot of storage at your location, you don't want to keep expanding that, then putting it in the cloud can actually be cheaper and definitely store as much, and it grows with you. If you need to store more and more, you can stretch it. So B and D are correct. And if the data is truly sensitive, like imagine the most sensitive data, then that should not be in the cloud if it can be stored locally as well, which means like, a cable going from a computer to a hard drive or an external hard drive in the office, right? Or a NAS, a network access storage unit as well. Case 68 is here. It says data has been collected about medicine trial results. The privacy of those in the trial needs to be protected. So the people's names, right? And some other personally identifiable information. So is data aggregation sufficient if the patient name is not used, but the zip code, the doctor name, and the pharmacy are used, and the data is password protected? Select 2 answers. So it's basically saying, like, is it okay? Is the aggregation, the collection of this information, is it okay? Is it sufficient if they remove the patient name, but then they still have all of this other stuff? So yes, because the name is not associated with it. Well, you could think, is in that database, is it still possible to find who it is, to find whose this information belongs to? Well, if you know the zip code and you know the doctor and the pharmacy, like all of this information could lead you to enough of the information about this person, right? And also this whole data set is of people who are in a medical trial and the results of it, right? So you're going to be very careful with allowing enough data to be out there, even removing the person's name, because people can still connect the dots and find out, you know, who these people might be. So we need to select two answers. So yes, because the name is not associated. Well, it's good that the name is not associated, but I don't know if it's sufficient. I feel like more might need to be done. So B says yes because the data is aggregated. That does not make sense. Just says yes because there's a lot of data that's put together. So it's not B. C says no because the zip code and pharmacy could be used to drill down to potentially identify patients in the trial. Well, that is true. Like that was kind of what I was describing before. And then D, no, because the data filtering could still search for doctors involved in the trial, and if used with a zip, could identify potential participants. So yeah, it was like almost like A kind of looked good, but C and D are stronger answers because they do talk about the weakness of aggregating data, and I think the zip code being there, which is referenced in C and D, zip code, like it might be the case that just removing the zip code makes this data a lot more secure, right? A lot more private, where people can't connect the dots. But having the zip code in there is a problem. And also, do they need to keep the zip code in this data file? Like, what is the purpose of it? If it's not being used and it's kind of irrelevant, then take it out and it's a win-win, right? Like then now the data is much more secure. Case 69 over on the left says, in putting together a team, the project manager wants to have scientists, gamers, artists, and computer scientists. What is the argument for creating this team? So why would you have a range of people like this on a team? So we need to select two answers. So it will help get budget money from each division. No, that's kind of like a little like gaming where sometimes there may be like scholarships or grants or something available for certain, you know, like types of folks to be involved in some work, but that's not really the argument for creating a team that is diverse. Okay, B says each can work independently on their part and then combine it. So this working independently is really frowned upon. We really want to collaborate. And that's the purpose of having a diverse team, is because when you mix up people, you usually get a solution that's way better than just having people work on their own. So B does not do justice because it's focusing on independent. That's not true. C, collaboration efforts help save time and produce better results. That is true. D, different perspectives will help develop a better product. That is also true. And it says pick two answers, so that's what we did. 69, C and D. For number 70, which two protocols are responsible for breaking data into packets and putting it back together at the destination and routing the packets to their destination? And so this came up in an earlier question where they were talking about what is the point of TCP and IP. And so remember, IP is about the routing and TCP is about breaking and assembling the packets. All right, so the answers are A and D. For 71, it says, why should public key encryption be used? So when you have public key encryption, you actually have a private key and a public key. You have two things. And so it's a way for data to be, and transmission of data to be jumbled up enough where to unravel it, to reveal what it really means, you would need both the public key and the private key. And without both of those things, it just cannot be cannot be understood or unraveled. So why should public key be used? So it is shorter than other ciphers. Like cipher is a way of rearranging data letters as well, but it's not that. It's not just that it's shorter. In fact, it might not be. B, it cannot be broken with brute force techniques. So brute force, that means just, for example, trying every word in the alphabet. And so public key encryption, those things, those are like a jumble of letters and digits. That's like a really long string of characters. So brute force, you can't just try every word in the dictionary because these are just seemingly almost random bunch of characters. And so it cannot be broken with brute force. That is true. So B is one of the two that they're looking for. C, it uses an asymmetric key, making it harder to decrypt. And that is exactly what it is. Okay, so try and remember that with a public key encryption, that they use an asymmetric key. And then D, it uses a metric key to make it harder to decrypt. So remember, public key is using an asymmetric. Okay, it is not D. All right, 72, we're almost at the end. 72 says at the top right, which of the following can be stored in a bit? So remember, a bit represents a binary digit. We know that that can either be a 1 or a 0. So the result of a number mod 2. So if you have 5 mod 2, that would give you, the remainder would be 1. If you have 5 mod 3, actually this question is only talking about mod 2, so let's try another one. So let's say 6 mod 2. Well, that answer is going to be 0, right? So it could be a 1 or a 0. Now you could try other numbers. You could try like 11 mod 2. But 11 mod 2 is going to give you 1. So it looks like we're just getting 1s and 0s out of 72, right? So A could definitely go in there. It's either a 1 or a 0, and we kind of tested it. You could keep testing, but it does want 2 answers. So for B, it says a Boolean variable. Well, Booleans are either true or false. Now, you can't write the word true in there, or the word false. Also, you can't even use the letter T and F because that would be an ASCII character, which would be several bits in a row, several 1s and 0s to represent the T and to represent the F. But because a Boolean variable is binary, meaning that it's either yes or no, true or false, 0 or 1, this could be stored in there as a variable where 1 is true and 0 is false. So therefore, the 2 answers are A and B. If it was holding a variable in C that could hold a range of possible values, that range of values means more than just 2 values. So it's not going to be that. A binary digit can only hold 2 values, 0 and 1. D, a computer that can be off, on or off, or in sleep mode. Well, that's 3 different options. You can't represent that as a 0 or 1 because there's 3 different things there. So it's not D. The answer is A and B. For number 73, 73 says sending data offsite is a disaster recovery backup strategy. So if you imagine that you've got like an office that, maybe it's a doctor's office seeing patients, you have patient records, you have a calendar, all this other stuff. At the end of the day, if you have all of that data backed up off-site, which means away in a different location to the doctor's surgery, if it's backed off there, then in a disaster, if the whole surgery blows up or if there's a flood and all the records get damaged, then the data is still protected, right? But there are some concerns when you send some data off-site. So here the question is asking in 73, which concerns can occur from this strategy of moving data off-site? And so we also have to select 2 here. So for 73, it says security concerns if unencrypted data is transferred off-site on a regular basis. Yeah, even if it's not a regular basis, it's still a security concern. So unencrypted data is a problem. So that would be A, especially if it's offsite. It means other people may be able to get access to it. And more specifically, if they get access to it, they can read it because it's not encrypted. If they got access to encrypted information, it wouldn't be such a bad problem because they wouldn't be able to read it. It would just be all jumbled up and they wouldn't be able to figure it out because it would be encrypted, meaning that it would take them, thousands and thousands of years to unencrypt it manually. So that's one element of encryption. Okay, we need to select another answer. So privacy concerns if the data was intercepted and decrypted, exposing personal data. Now that sounds scary and it does sound like it's a problem, which it could be, but it's not a privacy data when they're talking about storage. Okay, so they're talking about sending data offsite as a backup strategy. So they do talk about sending. So you could think about if it was intercepted, but usually sending data offsite is done through either a VPN or some other software that does encrypt it. But here it says privacy concerns if the data were intercepted and decrypted, exposing personal information. This does look like a little scary and kind of does seem relevant. So let's hold that one for a moment. For C, it says compatibility issues. As computers and softwares change, the data may be unusable on newer systems. That's not true. Like newer systems are what they call backwards compatible, which means that compatible, which means that you can open up older files on newer systems. Plus, how often does that happen, right? Like usually data is stored in spreadsheets or on Word documents, and those can be opened, even with newer software. D says compression issues with sending large quantities over the network to a server in a different location. So unless you compress data, it could take a long time for it to send, and that could be a problem, especially if this sending data offsite is happening, like every single day, or even backing up more frequently. So D is definitely one of the two answers. Now B is like a close one as well. Let me just scroll up a little. B right here, privacy concerns if the data was intercepted. Yeah, it's just the system is not built where it's intercepted. I'm trying to reason why it is not B. Security concerns for A if unencrypted is transferred on a regular basis. Yeah, I don't really like it. I feel like this is almost one of the answers. Sending data offsite is a disaster recovery backup strategy. Which are the concerns? Unencrypted data is one of the concerns. Privacy concerns if data was intercepted and decrypted, exposing. Yeah, like A, B, and D are all kind of answers. It wants two of them. Compression issues with sending large. Yeah, it's like really close. I think A and D stand out just a little more than B. Okay, the last question here, 74. How has cloud computing helped with communication? Select two answers. So for 74, it says by allowing asynchronous communication with email and text messaging. Okay, so what asynchronous means is it doesn't have to be at the same time. If you have a telephone call with somebody, that's synchronous communication. It's synchronized at the same time. It's happening together. Whereas when you have asynchronous, it means I can send a text message and the person doesn't have to respond instantly. They can respond a day later or 2 minutes later. So we wouldn't usually think about email and text messaging as cloud computing, but it is. These emails and these text messages are stored on a server on the cloud before, as the next person reads them. So A is definitely one of the options. Say select two, by allowing synchronous methods of communication such as video conferencing. So video conferencing, the data is kind of like processed through a server back and forth to two different computers, devices, whether it's a cell phone or a laptop, whatever. So the cloud and servers has made that type of communication, which is synchronous. It's made it possible. Let's just look at the others. So C says by reducing the need for translation services since data can be quickly accessed from anywhere. That's not really making sense. Like, what does translation have to do with, like, translation services since data can be accessed from anywhere? Data, this is often what they do in these questions, is they say something that makes perfect sense, like since data can be quickly accessed from anywhere. That is completely true, but they're connecting it to this by reducing the need for translation services. So because this is false, this top bit is false, the whole thing is false. And then D says by providing cloud-based presentation tools to use with local data. Like, this just doesn't make sense. Like, cloud-based presentation tools, I'm thinking about like Google Slides, but then what does that have to do with local data, like files on my computer? That's what local means, on my computer. So D doesn't really make sense. So oftentimes with these questions, you might see two that you kind of like, but you're not mad about them. They don't really feel like it's the right answer. But then after you read the others, you realize they're so ridiculous that it has to be those that you thought that maybe it could be. Okay, so that's the end of these 74 questions. I hope this has been helpful.